Okay, so I found more information regarding the giant arc that was roughly 3.3 billion light years. Well, it's 3.3 billion light years in length, but at the same time, it's 330 million light years in width. If you actually look at the image, it's kind of hard to make out at first, but there's what they used like blue dots to separate like the MG2. I don't know what that stands for, and the quasars. But it also was there to, or no, the blue dots were supposed to represent the quasars and all that, and the gray dots and all that were actually supposed to represent the MG2s, also the galaxy and galaxy clusters, which are other galaxies. And if you don't know what a galaxy cluster is, it's basically like a big cluster of galaxies. Like for example, our galaxy is merging with, and I always forget the name of it. It's merging with another galaxy. Meanwhile, you have like these supermassive black holes in the center of the universe, or the center of these galaxies. Maybe not all galaxies have them, but as far as ours goes, it's like basically our galaxy's imploding on itself. It's sucking all the material and sending it elsewhere. So, I mean, you know, even though black holes are a different video, I do think it wouldn't be surprising if they lead to parallel universes. But then again, there's so much we don't know about them. And at the same time, though, black holes are supposed to be faster than the speed of light because it sucks everything up into like an endless void. That's why you can't see it. And that's why some people speculate, even have suggested, even Stephen Hawking's even suggested there's a possibility they may not even exist because they just happen so fast. And then you have this. But anyways, so it's also worth noting that the people that originally discovered it were from a British team somewhere, I think in London, and it was somewhere over the galaxies are basically like the image that you're seeing was basically at 500 million light years in each direction. So that basically means that that image, except for the width, the length of it would be like 6 times longer than what we're seeing. So if that is true, and it does go in, or it might even just be, you know, depending on what direction you want to go in. I mean, if it's displaying 500 million light years or if it's displaying 1,000 light years, you're talking about a galaxy that is basically like 60, like it might even be 60 times bigger than we're perceiving it or something like that, because you have to understand 500 and, well, actually no, it'd be 6 times, it wouldn't be 60. You're thinking about an arc that it might actually be proof, if it isn't already, because everything in space moves, and there's been speculation that a lot of galaxies are moving farther away from each other. But it seems like the more powerful a telescope that we get and we put it out in space, we basically would be able to prove that, you know, where there looks like there's absolutely nothing, there is a lot more in there. So it's proof that maybe the universe really is infinite and there's an infinite number. Because again, it seems like every time when we find new discoveries, we're learning something new and we're not hitting a wall where we think that there's an end to it. Because there's always that question, what came after that or what came before that? And it seems like there's no end in sight. So it's no reason to believe, it's no reason to believe that everything can only happen once and then that's it, you know, when it could probably happen an infinite number of times. So who knows? You know, the observable universe always keeps getting bigger. And here's something else to think about. With this cluster of galaxies, it's proven that cosmology has to up the length of the universe and how many galaxies at its average rate. So, like, basically, I'll give you an example. So, like, they say right now the observable universe is 93 billion light years. And last time I checked, it was supposed to be like 4 billion galaxies were in it, or trillion galaxies. But then they upped it to like, well, then they sort of shifted it to 2 instead. So basically, for every 2 trillion galaxies, there's a length of 93 billion light years. And what I find really fascinating is it might even be much higher than that, because with the way they use supercomputer machines to like identify what it thinks, and then it counts the dots and all that based on pixel zoom in ratios. And it labels them different colors. So you basically have like a dot graph or a bar graph of some kind. So it's really fascinating how they build these telescopes. They can take really high-tech quality pictures. They can, while everything in space is moving. And I don't know if there's like a slowdown rate. Again, I'm not a photographer, but I definitely couldn't tell you like specifically the kind of technology they use to do this, like how it's programmed, how it's built. But based on the information that I'm able to find, I wouldn't be surprised in the slightest that, you know, there's an infinite number of galaxies out there waiting to be discovered. And you know, those galaxies are probably a lot bigger than we could imagine them to be. And we can only imagine like what else is going to happen with them. So, you know, where they lead to and what's in them, what kind of galaxy or what will you find in it. It's, you know, I guess it gives life meaning and progress. So, you know, if I find any more information, I'll make another video, but this is like based on what I was able to find. So hopefully if anybody has any questions about it, that'd be cool too. But again, if you're not subscribed to this channel and you like these kind of videos, I'll be making more, so please